Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day everyone. Hi, Dr. Zuhair here, and this is for the course of EMM3518 Computer Aided Engineering Drawing. So we are now in lecture 5, and it's about the multi-view projection and auxiliary view. If you still remember, during my first and second lecture, I already introduced you about the orthographic view, consisted of 2D views of different sides. So this is what we call as a multi-view projection, in which we have different sides that we can view in order to view the object. So imagine this is the object. So we have we can view it from the top, from the front, from the right side, from the rear, from the bottom, and from the left side. So this is what we call as a six principal view, in which you can imagine that the box is in a glass box, and then you try to open the box with all the views. So we have the top, the front, the rear side, the right side, the left side, the rear, and the bottom side. So this is the basic six principal view. However, when it's come to the arrangement of the view, you know, we have two type of projection. One is called as third angle, and the other one is first angle projection. And the difference between both is because of the standards. And for the NC standard used by the American National Standard Institute, they prefer to have the third angle projection, while some other country, especially European, including Malaysia too, we are following the ISO standard, which prefer more on the first angle projections. So it's just a matter of rearranging the view actually, but I would like to show you a video on how to differentiate between these two type of projection.
Hello and welcome to Clan McCad. Okay, so today we're going to have a look at first angle and third angle projection in engineering drawing. We're going to look at first angle first, and what I want you to think of is having the actual object you're going to draw on top of the paper itself. All you're going to do is imagine yourself rolling the object in the direction of whatever view you're looking to create. And what you see from the top down is what you draw. Okay, so for third angle, I like to think of it as if you're unfolding a cardboard box into that traditional flat pack pattern, looking at the front view itself as if that's all you've got to start with. What would be on the right hand side of that object would come out to the right, and what would be at the top will come out above it. Now viewing these side by side, you can understand why some would compare them as direct opposites to one another. I like to think of them, as I've shown you, in two different ways entirely, and I hope that helps you remember it. In my next video, I'm going to use the exact same setting to lay out a small mechanical component in separate views. It has some asymmetric features and holes and things that will help it really get across a realistic example of how to do this. Thanks for watching, and I'll see you next time.
So we have another video that is having a more details about the differences. Sorry.
Hello and welcome to Clan McCad. So today we're going to have another look at third angle and first angle projection using this little guy here. Now this is an X-ray view of the object. Everything in light grey is the solid body, and everything in dark grey are holes travelling through the object perpendicular to our current view. Now on the left hand side you can see a feature that ends with a dome and a hole that travels not all the way to the edge, so that will be concealed from any external viewing. On the right hand side however we have a cylinder where a hole does travel all the way out to the edge, which we'll be able to see right through from the external side. At the top there we have another hole travelling through, which just allows asymmetry in that direction as well. One side will have a hole, the other will not. Okay, so here's a quick look in 3D, just to back up what I've just told you. So once again, let's look at first angle first. Now we're going to use the same front view in each example. The cylinder is going to lie on the right, the dome at the left, and the hole at the top, as far as unique features go. What we've got to remember is to use that 90-degree roll in the direction of whichever view we're trying to create, and whatever you see looking straight down from the top is what you're going to draw. The result of this, as you can see, is that each respective feature on the front view lies on the opposite side on each projected view. So the cylinder on the right, the drawing of that facing you lies on the left, the hole at the top lies on the bottom. Okay, so moving on to third angle, again we're going to use that exact same front view, and using that cardboard box thought pattern I explained in the last video, you can quite easily see that what we're going to do is we're going to pull out the nearest side to the view we want to create by 90 degrees until it faces us, and again just from the top down, looking down, what do we see? That's what we draw. Now what you'll notice from this method is that the features on the front view actually lie in the projected view that's on the same side as it is on the front view. So the cylinder on the right there is in the right hand projected view, and the hole at the top is in the top projected view. Okay, so once again I'll end this on a comparison so that you can kind of decide for yourself how you would maybe like to remember it and see the difference between the two. So that's probably us for third angle and first angle for at least a while. Let me know what you thought of the videos, and if you have any suggestions as to what direction you'd like me to take on any videos CAD related or drafting in general, you know.
Okay, so that's the differences between first angle and first angle projection, in which you can see here. For me, the simplest way to differentiate is to see the arrangement of the view. If you can see from the first angle, when we have the front, the bottom view will be on the top, while the top view will be on the at the bottom, and the left side will be on the right side, and so on. So this is opposite the third angle view, in which it's follow the exact view. The front view will be in the middle, and then we have the top view on the top, the bottom view at the bottom, right, left, and rear. So it's just a matter of arranging. If I give you third angle, if I ask you to change to first angle, what you need to do is just to rotate this to here, and this to this. Okay, so it's just a very simple way of understanding the differences between first angle and third angle. And if you notice, we have a symbol here. If the symbol, the circle symbol, is on the left side, that means that this is a first third angle. If the circle here is on the right side, that means this is a first angle projection. If you were referring to any engineering drawings later in the future, you please be alert about this symbol to see whether the drawing has been projected as a first angle or third angle projections. Okay, so this is the way to do the multi-view projection on the drawing blocks, in which what we can do is to do some scaling and also some dividing. And you can see here the space between each view should be enough to have some space lah, some space, so that we can clearly, and it's going to look very neat. And in the same time, I would like also introduce the meter line. The meter line is the 45-degree line in order to that can connect the side view and the top view, so that we can if this is a manual drawing, we can transfer all the information from one side to another. And we are going to do this later during our lab work, in which for manual drawing, if I just give you two view, let's say the front view and the side view, I want you to draw the top view. You need to do some construction of line, so that you can get all the information. In fact, like this one also, you need to get the information, and also this one. And you in this is very common things to do when it's come to manual drawing. Okay, so this is the way to create the manual multi-view projection, in which we can follow it step by step. So this is the object. The first step is to draw the block, the top view, the front view, and the right side view according to the bigger frame of the object, the biggest frame of the object. And then step 2, we kind of like refine it according to the details. And then what we can do, we include the meter line here so that all other information can be transferred, like this one to here and so on. And then after that, we can kind of like use use the construction line to project, and then finish adding the final lines. So we kind of like polish it a little bit so that this is the completed 3-view sketch. So this is a step-by-step ways of drawing 3-view projection drawing. Okay, so this is at the end, you're going to get something like this. It's very neat, it's very clear. This is the front view, this is top view, and this is the side view. At the end, we will have to omit all the construction line that we have done before, the meter line and so on. Okay, and in fact, if you were to use AutoCAD also, we can also do the multi-view as well. So now we move to the next view. Beside the 6 principal view, we also can have another view which we call as auxiliary view. And why should we have it? To show the true length of an oblique line or the true size of an inclined plane. Why? I'm going to explain you later. Because sometimes when we, in many cases, the auxiliary view will replace one of the regular view, the front, top, and side view on drawing. So imagine this is the 6th principal view, third angle, in which this multi-view, a true size and shape plane is shown only when the line of sight used to create it is perpendicular to the projection. So this view will only represent the true size of the object if the view is perpendicular to the projection plane. However, if we have something like this, oblique line, inclined planes, or oblique planes are never shown in the true size. So if we have this area and we want to project it according to the 6th principal view, the size of this area will not be presented in the true size. And that's why we need to have another view which we call as the auxiliary view, in which beside the, okay, so this is the 3 view, the front, the top, and the side view. And beside that, if you want to know the the details of this part, we need to have another view where we call this as the auxiliary view to represent the true shape and size of this area. And sometimes this is very important because maybe this part is very important for us to know the details of it, so we need to have this auxiliary view. Okay, so the for example, like this object, again I give you an object, so we have the 6 principal view to represent all the parts, all the side. However, this part cannot be represented in the true size by all of this view, yeah, because this is not parallel to any side. It's not parallel to the front, to the top, to the side, and so on. So that's why we need to have an auxiliary view here that is parallel to that plane, so that we're gonna have the true size of that particular area that we want. We're going to do a little bit more exercises related to auxiliary view in our lab work later. Okay, so the way to do it, one of it is a 4-line method, in which is just the method similar like the 6 principal view. We have the 6 principal and we add one more. The view will be perpendicular or direct to the plane that we want to have the detail. And beside that, okay, so this is another type of 4-line where we have a reference plane method in which sometimes we don't want, it depends to the plane that we decided to view. Sometimes it will be at the side, sometimes it will be in the middle, and sometimes it will be at the other side. It's according to the reference plan actually. So this can also be done because at the end of the day, the most important thing is to get the true size of the parts that we want. So what are the auxiliary view application? Some of it is used for the reverse construction. From that auxiliary view, we can also construct the other side view, such as the front, the top, and the right side. And also this is for the true length of a line. This is the true size that I was talking about before. The point view of a line, edge view of plane, true size of plane. Okay, so most of it, in conclusion, why we need the auxiliary view is just to want to get the size and the length and everything, all the information in that plane that cannot be represented by the six principal view. Okay, and how to construct the auxiliary view? So there are steps of doing that. We follow it one by one. Okay, so step one, if you can see here, we already have the front, the top, and also the side view. So what we need to do is to draw a fall line, this line, using a phantom line parallel to the edge. So it's gonna be this line will have to be parallel to this line. Okay, and then draw full line between the front and top and front and right. So after that, we can detail out the other type of line so that we can have more detail and we can easily draw it later. And step 3, project the length. Okay, so after that we project the length. So according to, because it's parallel to each other, so we project it. Okay, step 4, we transfer all the information such as the distance between point C to this line. So point C to this line should be the same. And then other step 5, other type of details also need to be to be obtained. So like this one, we can then draw BC line, and then for this one D here. So we can get at last we can get the true size of that plane as what we want. So again, this will be done during our manual drawing lab. So this session is just to give you some understanding on how to construct an auxiliary view. Okay, so these are some example of the auxiliary view. If the object like this, so we need to get the true size of this plane, in which cannot be obtained by the six principal view. So how to do it? This is the way to do it. So at the end, we are going to get this. So beside that, we also have the partial and half auxiliary view. Partial auxiliary view when only the details for the inclined surface are projected and drawn in auxiliary view. So that's mean that not necessarily means that we want to have all the view from the plane that we want to have. Sometimes we just need part of it. For instance, like this one, this is the full auxiliary view. However, it's a bit too complicated and we don't want this part. So what we can do is just to omit this part and just represent the partial auxiliary view, which is this part, the one that the part that we want. And hidden lines are not shown in the auxiliary view unless absolutely necessary. So sometimes the hidden line will cause the view to be harder for us to read, so we just omit the hidden line. Okay, and beside that we have also a half auxiliary view, normally for symmetrical object in which only half of the object is shown. Sometimes we don't have to draw the full because the information is just the same, so half of it should be enough. So that's why some of the drawing they just provide half auxiliary view. And sometimes the object have many sides that cannot be represented by the uh, by the six principal view. So we can have more than one auxiliary view. For instance, like this example, we have one auxiliary view here and another one auxiliary view here, because we have the two side that we want to know the true size. Okay, so that's about the auxiliary view. We move next to the revolution. Okay, so it's similar like the auxiliary view. However, this time it's a method of determining the true length and size. It's the same aim to determine the true length and true size of the inclined and oblique line. However, instead of we draw it according to this plane, what we can do, we move the front view according to the axis of the view that we want. Okay, so it just imagine that this is the auxiliary view and we rotate, we revolve it, so that this front view will have to move 30 degree, and this view will be like a side view. So the object is moved with respect to the viewing plane. Okay, so this is the difference between auxiliary view and revolution. This also can be done in engineering drawing. An easy way to picture an object being revolved is to imagine that a shaft of an axis has been passed through it. Okay, so like this one, we want to get more information about this plane, which is not represented in this view. So we move the plane so that we can have the axis, and then we can draw it according to the true size of the plane. So this is the revolved view. Okay, and the axis of revolution, it can be perpendicular to the horizontal plane, it can be perpendicular to the vertical plane and profile plane. Well, actually, it's also flexible according to the suitability of the drawing. Okay, so that's about it. Today we have learned about the multi-view, the auxiliary view, and the revolution. Hopefully you get some understanding and some exposure about this type of view, and we are going to do a lot of exercises related to this type of view in our manual lab, manual drawing, as well as in the AutoCAD too. Okay, thank you for watching. We see you in another video.